Thanks for tuning in for another episode of Math with Mullins. Today we're looking at our quiz review for lessons 11.1 through 11.4, and this is on page 624, questions 1 through 15. So let's go and get started. For number 1, we can find the measurement of angle arc EF if we take the measurement of EF over 360 is equal to 2 times pi times radius, okay? So what we can do here is then look at, we know the measurement of the arc is 13.7, so that's equal to x, not knowing the degrees, over 360 times 2 times pi times radius of 7, okay? What I'm going to do first is multiply both sides by 360 to get rid of these 360s. So that ends up giving me 4,932 is equal to x times, and then I'm going to do this guy, 2 times 3.4 times 7, which would be 43.96. And then I'm going to divide both sides by 43.96. So that x is equal to the degree measurement of about 112.19. Okay? I'll have to erase some to give me some room over here, so if you need to rewind the video, look back at it, go for it. This next one, I do know the degrees, but I don't know the arc length. So x is equal to 83 over 360 times 2 times pi, make that look like an x, not a dot, times the radius of 4, okay? Once we do that, I'm just going to multiply straight across, so 83 times 2 times pi times 4, and then divide everything by 360. I'm going to get about 5.79 centimeters, okay? And again, number 3, we want to find the circumference now. We know the arc length is 8 inches. We know the degree measurement is 48 out of 360, but I don't know the circumference, so I'm just going to say times c. In order to solve this, it'd be helpful if I just multiplied by the reciprocal of 360 over 48. So timesing by 360 over 48. So you're essentially doing 360 times 8 and then dividing by 8. So we're going to type that into our calculator, 360 times 8, and then divide by 48. I'm getting 60 as my circumference. Converting radians and degrees, so if we start with degrees, 26 degrees, we're going to times that by pi over 180. So I get 26 pi over 180, but I want to make sure I simplify that well. So I'm just going to divide both 26 and 180 by 2 to see what I get here, and I get 13 pi over 90, and that is in simplest form. If I have radians though, 5 pi over 9, I'm going to multiply by the reciprocal of what I just did, 180 over pi. The nice thing about this, and the reason why this is happening, is these pi's get canceled out, so I'm just doing 5 times 180, which is 900, and then over 9 gives me 100 degrees. Okay. Number 5 and 6, we were finding the areas of our red and blue sectors. So red is our smaller one. So I'm going to take 100 out of 360 and times that by my area. So 12 squared times pi. And I'm going to get about 125.6 yards squared. Move this out the way. And then area of the blue sector, that would just be the leftover degree amount. So 100 take away from 360 is 260. So 260 out of 360 times 12 squared times pi is about 326.56 yards squared. Okay. 7 through 9, we're going to use the same segment here and just identify a few things. So I'm going to put the center is C. A radius could be CY, or you could use CR. An apothem, I said was CZ, because you're going from the triangle or the polygon that's being made to the center. And then a center angle you could say maybe is RCY, or if you did YCR, that's the same thing. Now we want to find the measurements of RCY, RCZ, and ZRC. So RCY is first. RCY is that center angle, so since this is a octagon, I divide it by 8, and I'm going to get about 45 degrees. The next one is RCZ, so that's half of 45 degrees, so 45 divided by 2 is 22.5. And then the measurement of ZRC, ZRC is a triangle, so you're thinking about if I already have 90 and 22.5, I'm going to take 180 minus 90 minus 22.5, and I'm going to end up with 67.5 for ZRC. Next up, the radius of the circle is 8 units. Find the area of the octagon, okay? So this is where we want to maybe think about, here is Z, R, and Z. I know this is 90. I know this is 67.5. And then I know this one up here is 22.5, okay? The radius is 8. So that means from C to R is 8. So now I just need to figure out, well, what the heck is everything else? Because then I need to be able to use my apothem formula and find the area. So what I'm going to do is I'm going to start with 22.5, and I'm going to do sine, which is opposite over adjacent. So the sine of 22.5 is equal to x, don't know that yet, over adjacent. I'm going to cross multiply here. Grabbing my calculator first. So 22.5 sine, and then times 8. I'm getting about 3.06. So that means this leg is 3.06, but this is only half the side, so I'm going to multiply that by 2, and that each one of my sides are going to be 6.12. Okay, so that's one thing I needed. Then the next thing I'm going to look at is to find the measurement of C to Z. So we could maybe use cosine of that. So let's do cosine of 22.5 is equal to adjacent over hypotenuse, so x over 8. So again, multiplying cosine of 22.5 times 8, and I'm going to get about 7.39. This is your apothem. Okay, so now I can plug that into the big formula that I was given, where we find area of regular polygons is 1/2 times A, which is the apothem, times the number of sides times the side length. So that means I'm going to do 1/2 times 7.39 times the number of sides 8 times my side length of 6.12, and I'm going to get 180.91 units squared. Okay. Next three are pretty easy. 10, 11, and 12 are these polyhedrons, and if they are, name it. For number 11, it's a no, because it doesn't have any of those straight edge faces. But number 11 is yes. We can call that an octagonal pyramid. And number 12 is also a yes. This would be a pentagonal prism. Okay. 13, sketch the composite solids produced by rotating the figure around the given axis. This is kind of like we would keep going around and around and around. So this first one is going to be looking like a cylinder. So I have my radius of 3 and then my height of 3, because my whole entire thing is 10 and I've already taken away 7. And then this other one would also look like a cylinder, so we're kind of like making maybe like a tiered cake here. So cylinder as well. And I apologize for my terrible drawing, but you get what you get here. Height is 7 and my radius is 6. Okay. Next up, 2 white congruent circles fit in the blue circle. What's the area of the blue circle? So first I got to find the area of my 2 small circles. So I'm going to do that by pi r squared times 2. So 3.14 times 3 squared, and then times that whole entire thing by 2. I'm going to get 26.52 for just one, but if I multiply that by 2, I get 28.26, my bad. And then 56.52 is the entire thing. And then my big circle would have radius of 6. So that would just be like, if I went all the way across, that's radius of 6. So that's pi, so 3.14 times 6 squared. I'm going to get 113.04. And then I'm just going to subtract these two guys. The leftover amount is 56.52 square meters. Okay. Last one has some rhombus and kites in here. So it says find the area of each rhombus, or just rhombuses. So here you needed to count the number of yellows and then do your 1/2 times D1 times D2. So let's do 1/2 times 11.4 times 15.7. I'm going to get 89.49. And then there are 32 of those yellow ones. So yellow is 2,863.68. And then for my red, 1/2 times 6 times 18.5, which would give me about 55.5, but there's only 21 of those. So multiply that by 21, I'm getting 1,165.5. Add them all together, 4,029.18 square millimeters. Okay, that'll be all for today on your quiz review for 11.1 through 11.4. Hopefully this video helped you. If it did, give it a thumbs up, and good luck on your quiz tomorrow. Have a great day.